Hi everyone. So I'm going to introduce a new type of video into my channel, and this one will probably be called Experiments and Theory or something like that. And I'm going to cover some basic principles of electronics, but it won't be a tutorial, it won't be investigating, it won't be posted here, it won't be repairing, it will be a different category completely. And the idea is I'm just going to chill out, I'm going to share with you some interesting bits of theory, and hopefully it'll be fun. Anyway, the first one is going to be about powering LEDs, and it sounds very fundamental, and I suppose it is fundamental actually, but it's very interesting, and hopefully you'll like this video. So one thing that I see a lot of online, and people sometimes ask me questions as well, sometimes I get emails and stuff, why do I need a resistor? Well, of course you don't always need a resistor. It depends on what voltage you're going to apply to the LED. And these have different voltages, and therefore if you've got a set power supply, let's say for example 6 volts, if you were to apply 6 volts to this, you'd kill it. It will just burn out. And the reason being is because it's only rated for a certain amount of current. If too much current passes through, it burns out. And I suppose it's a bit peculiar, because when beginners start to do experiments with different components, components tend to draw whatever they need and not more, but an LED is not like that. An LED will just draw everything and kill itself. So you need a resistor, a current limiting resistor, and this seems to pose a lot of confusion for new people, and I'm going to explain it, okay? So to start with, I've printed out a spec sheet or a data sheet for a random RGB LED. Now, they all have different specs. It certainly does have a different spec to this one here, but I'm just showing you as an example. So if we look through this spec sheet, you should be able to see this. So I've drawn on the back of this, but anyway, you should be able to see this. Forward voltage, forward voltage, forward voltage, forward voltage. And then another important thing is the continuous forward current maximum, 30 milliamps, 25 milliamps, 30 milliamps, 30 milliamps. And these things are very important for choosing a resistor which will protect the LED. So yeah, this is what I'm going to show you. Now on my particular LED, the ratings are not that. Usually the ratings are around about 20 to 30 milliamps for pretty much all of these types of LED, pretty much. But the forward voltage is different for each type of, or each colour of an LED. And generally speaking, but you can't really, it's not a hard fact, but generally speaking, all red LEDs will probably be a lower voltage than green and yellow, and certain colours have their own, I don't know, differences if you like. Anyway, so on the back of here I've written the voltages, the forward voltages of this particular LED here, and I'm not going to go into depth on how I found that because I don't have the spec sheet, but suffice to say I know the forward voltages of this LED. So now if I've got the forward voltages, and let's say we've got a 6 volt power supply, then how can I stop this thing from burning itself out? Well, the answer is to use a current limiting resistor, like I just mentioned a minute ago, and I'm going to explain to you, hopefully simply, how you can just work this out for yourself, because a lot of people use online calculators and they don't really understand, but it's actually not that difficult. All you need really is a knowledge of Ohm's law, and the rest of it you can work out yourself. So I'm going to try and explain this to you now, and hopefully you'll like it. Okay. Now let's say I want to power the blue LED, or the blue component of this LED. So the forward voltage of the blue LED, usually you'd use the spec sheet to work this out, but I know for me the blue one is 3.4 volts forward voltage. And I also know that I want to draw about 20 to 30 milliamps. I want to draw 30 because I think it can handle it. So yeah, 0.03 amps, okay? And that's volts of course. And if you can tell, I assume you probably can, I'm actually drawing Ohm's triangle. And in Ohm's triangle we've got voltage in there, and then we've got current in here, and we've got resistance here. Okay, so we know the forward voltage, we know the amperage we want to draw, so we should be able to work out the resistance. Now, before I carry on, I'll just stop here and tell you something. This isn't a typical resistive device in the sense that it doesn't actually have a fixed resistance. However, we do know that we want to achieve 3.4 volts, we want to give it 3.4 volts, and we want it to draw that. And therefore, just for a theoretical purpose, we can make use of this. Not that it will have any real relevance at the moment, but we can still make use of it. So I'll just get my calculator and we'll work out the resistive value, or what resistance it would be theoretically. So I'll just get my calculator. So 3.4 volts divided by 0.03, because it's milliamps, and we get a value of 113. So 113 ohms. Okay, so we've just solved some sort of equation, and we filled in Ohm's triangle for this particular LED at 3.4 volts for blue. And at the moment it's not incredibly useful, but what we've worked out is what the resistance would be, or the effective resistance would be, if these two parameters were in such a state, which is the state provided by the data sheet. Anyway, so I'll leave that there for now, and we'll move on to the next thing, and we'll probably go back to this value in a minute. So now I'm going to do another Ohm's triangle just to show you. Okay, so let's say we have a battery voltage of 6 volts and we want to power that LED. Of course, if we were to connect it directly to 6 volts, we'd blow it. So let's just do something again. So another Ohm's triangle, and here we have a voltage of 6 volts. Now the current, the amount of current which runs through a series circuit, in which case, you know, if we had a battery and it just runs through series through this LED, the amount of current would be the same throughout the whole circuit. That's just the way it works. Now, in our case, what did we say it was? 30 milliamps. Yeah, 30 milliamps. So here we know that throughout the whole circuit, we want to be drawing 30 milliamps. Have I done that right? I've written 300 milliamps there. Hang on a second. 0.03 amps. That's better. So we know that we want to draw 30 milliamps through the whole circuit. So therefore, we can do this again and work out an equivalent resistance. So I'll just get my calculator again. I'll make this clear in a minute as to what we're actually doing. So 6 volts divided by 0.03 equals 200 ohms. So the total resistance of the circuit which we've created for the 6 volts would be 200 ohms. Okay, so just like many other formulae in mathematics and stuff, if you know two things of three, you can work out the third. It's just the way it works, and this is no different. So like we used these two before to calculate this, and like we used these two before to calculate this, you can actually use these to calculate something else. 6 volts take away 3.4 is 2.6 volts. So we want to drop 2.6 volts. 2.6 volts. Let's do another triangle. 2.6 volts, and we want to test that we've got the resistance correct. So I'm not going to use resistance, I'm going to use the milliamps again, so 0.03 amps. So now if I use Ohm's law again, 2.6 divided by 0.03, now it should give us 87 ohms. So let's just check this out. Get my calculator. So 2.6 divided by 0.03 equals 86.66, or 87 ohms. So 87 ohms. And there are our three sets of calculations on how to work out the amount of resistance required and whatever else in order to power an LED properly. So, like I just mentioned, we didn't have to do it that way just then, because you know, if you know two parts of the three, you know, you can do it in different ways. You can work it out in different ways. I could have also done it in a different way. I could have done this. I could have said Could have done this, 200 take away 113, that would have also given me the answer. So if you knew 2 parts, you can work out the third. Anyway, so I've done enough waffling about how the mathematics work in this, but what about in reality?